Hi. When I say the word progressivism, what comes to mind? Yes? Progressing through a job. Maybe some people think about computers, how the very first computers took up the space of an entire room. And today we have computers that fit in the palm of our hand. When I think about progressivism, I think about agriculture. Now, I have a little bit different background than most, as I have been born and raised on an operating farm and ranch in Linden, California. My family grows walnuts, almonds, peaches, cherries, hay, and beef cattle. Being around all this food constantly, I naturally fell in love with cooking and spending time in the kitchen. At 9 years old, I joined the 4-H cooking project, where my skills began to excel. A few years later, I found myself in Food Network studio filming Chopped Jr. the summer before my freshman year of high school. I ended up winning the show, and when I came back to California, I began to work as an advocate for agriculture, reconnecting consumers to where their food comes from and how it's grown. I've even launched my own communication business to further my efforts in advocacy for agriculture. In the agriculture industry, we have a lot of difficulties that we have to overcome. One of the major ones is labor. During harvest season, it can be difficult to find laborers to pick and harvest the fruit and to process it before it can make it to the grocery store. Because labor is hard to find, labor becomes more expensive. And as the population continues to grow, we have more mouths to feed. With more mouths to feed, we have to produce more food, and oftentimes with less agricultural land and less farmers. So farmers need to work to become efficient in their practices. So I want to take you on a field trip today through Linden, California, and some of the packing sheds near my house. First stop is going to be the cherry packing shed. Now, the cherry packing shed brings in cherries from the orchard and hydrocools them first. Hydrocooling is a process which brings down the temperature of the fruit to maintain quality and freshness. This is done through the use of cold water. Once the cherries are completely cool, they go through an optical sorter machine. This machine takes on average 32 photos of each individual cherry. It uses near-infrared cameras and high-quality cameras to take these photos. So as the cherries travel through this machine, they're placed into a little cup, which allows the camera to take better quality photos. We sort cherries by size, color, and quality. The first up is size. The near-infrared cameras take a picture of the cherry from the top down, which allows us to more easily identify what is flesh, or the fruit, the part that we're going to eat, to what is background and not the fruit. The larger the cherry is, the smaller the size number is. For example, a size 6.5 cherry is considered fairly large. The second way that we sort cherries is by color. High-quality cameras take pictures of cherries, and the color is dependent on the number of dark red pixels in the photo. So for instance, if we have a photo of a cherry and it has 60% dark red pixels, we will classify that cherry as a dark red cherry, and it will be moved to the lane with other dark red cherries. Consistency is super important in the food processing and agricultural industry. Consumers like uniform fruits and vegetables and nuts, everything in between, and having it consistent brings more satisfaction to the customer. The third way that we sort cherries is by quality. A group of about 10 employees make sure that the optical sorter and sizer machine runs correctly, fixing any camera issues or mechanical issues that may arise. A group of employees also goes through and double checks the work of the machine. The cherries come through on a conveyor belt with either a green or blue background, and the employees look for maybe any special bird droppings, cracked, or extra bruised cherries. There's also a scale on the conveyor belt so that employees can check the weight of the product as it goes through the packing shed. Because we export so much of our agricultural products produced here in California and across the nation, it's important that we do some firmness testing on cherries. The firmer cherries can withstand longer periods of transportation. So, for instance, they may be exported to countries like China or Japan, whereas softer cherries might stay in a local market, maybe here in California or into Arizona. So I think we have the cherries covered, right? The next place we're going to go is to the walnut packing shed. So walnuts grow on trees, and when they're ready to be harvested, in California we harvest about October into early November. We use a shaker harvester to shake all the nuts off the tree onto the ground. This machine goes around the trunk of the tree and shakes it in a specific pattern so the nuts fall to the ground. This machine does not damage any of the bark or the trunk on the tree. It's the most effective and efficient harvesting method. Once the nuts hit the ground, we sweep them up into a windrow and pick them up and take them to a dryer. Walnuts are very unique in that they have a higher moisture content as opposed to other nuts. Before we can process and package the walnuts, we need to dry them to lower the moisture level. This can take anywhere from 4 to 6 hours up to 24 hours or more. It's dependent on the weather and the moisture in each lot of nuts that we harvest. Once the nuts are dried, they go to the processing facility. And if you see here on the left of the packing shed, we have a cracker machine. In order to crack the shell on the walnuts, we place them into a cracker, which is essentially 2 bowls stacked on top of each other, and the nuts are in between. The top bowl pushes down and cracks the nuts. So now we have the kernels, or the meats, the part that we eat in our walnut, and the shells and membrane, what we call foreign material. The walnuts travel down a shaker deck through a laser system. Now, this laser system uses 3 different colors of lasers: red, blue, and green. These 3 different lasers have different energies and thus different wavelengths. If you've ever pointed a laser at your hand, you'll know that the laser light is absorbed into your hand. But if you flip your hand over and point the laser at your fingernail, the light reflects. The same concept works when lasers are shot at foreign material, either that membrane or the shell. When the technology recognizes that a reflection is coming off of the shell or membrane, it shoots a tiny air gun out, a spiff of air, and it removes that foreign material into a coal bin, and we're left with just the walnuts. This repeats for several times until we are almost 100% certain that we just have the walnut pieces left. Again, in processing walnuts, it's very important to have quality control. Another group of employees double-checks walnuts after they go through the laser machine. It takes about 10 employees a line as well, and the walnuts move through on a conveyor belt. This conveyor belt happens to be green, but they can also be blue. The color helps the human eye more easily detect the defects. When I talk about defects, we're talking about maybe orange or yellowing in the product, dark brown, or getting into the edge of black walnuts. Quality control is a huge issue. With every lot that goes through the processing facilities, we know what farmer it came from, what farm it came from, when it was harvested, when it arrived in the packing house, and the variety of the product that it is. For instance, it could be a Chandler walnut or a Tulare walnut, and that would be part of the quality control. We also do lab tests to ensure that agricultural products are safe for consumers to eat. I myself have worked as a progressive agriculturalist by purchasing hydroponic towers in my high school. These towers run on 20 gallons of water each, which are fortified with minerals, so we can grow 20 varieties of plants without any soil. They're equipped with LED lights so they can grow completely inside, and they have timers for the lights to turn on and off, and timers for the water to circulate through the tower. The plants and herbs that I grow on my hydroponic tower goes back into my school cafeteria, and our school chef turns it into our lunch. There are so many opportunities in agriculture, many of which you probably never thought about before today. Agriculture is so vast. We all enjoy to eat our 3 meals and all the snacks we want a day, and we all enjoy to have clothes on our backs. Without agriculture, that wouldn't happen. As our population continues to grow, we need to grow more food. And in order to do that, we need technology like the optical sorter and sizer, the shaker harvester. I challenge you to look up some careers in agriculture that you may want to pursue in the future. We need truck drivers with Class A licenses to transport the product from the farm to the processing facility and from the processing facility to the wholesaler or to the grocery store. We need biologists and chemists to develop new breeds and varieties of plants that can withstand drought, disease, and special pests. We need fertilizer specialists to work with farmers to pick out a good combination of fertilizer to help the farmers' plants grow tall and strong. Where will progressivism take you in the future? Thank you.